Everybody, in this video I want to show you how to solve a quadratic inequality where you have the coefficient of x squared greater than 0, delta is greater than 0, and you have the inequality with the greater than or equal to sign. We'll see that the solutions are given for external values, but we will see external with respect to what. So let's consider this inequality, and you can check that the delta is greater than 0, and obviously the coefficient of x squared is 1, so it's greater than 0. So we want to show why the solutions are given for external values, and which are these values. So the first thing to do is factor this polynomial in two factors, as I showed you in one of my videos. So the two factors in this case are x minus 2 and x minus 3. These 2 and 3 come from the fact that 2 times 3 is 6 and 2 plus 3 is 5. But you can check that in that video. So let's call this first factor first and this second factor. Now we have to think, when is the product of two numbers positive? That happens when both numbers are positive or when both are negative. So what we do is study the so-called sign of these two factors. So we solve these two inequalities. First factor greater than or equal to 0, and the same thing for the second factor. So the first factor is x minus 2 greater than or equal to 0. So x greater than or equal to 2. Second factor is x minus 3, and that means x greater than or equal to 3. So what we do now is we draw a line, which is the line of real numbers, and we write on this line the two values that we found here. By the way, these are the values which we're referring to here. So we have 2 and 3. And then, just to make things easy, we draw two vertical lines. Then what we'll do is draw two other horizontal lines which corresponds to these things. The first line will correspond to the first factor greater than 0, and the second line to the second factor greater than 0. So the first for the first factor greater than or equal to 0, we saw that happens when x is greater than or equal to 2. So we start from 2, we draw a full ball and a solid line to the right, because that is true when x is greater than 2. Then we draw a dashed line on the left. To make it simple, we can also write here plus, plus, and minus, because this is positive after 2 and negative before 2. Then we do the same thing for the second factor greater than or equal to 0. That happens when x is greater than or equal to 3. So a full little ball here, and then a solid line to the right, because that's x greater than 3. And then a dashed line for x smaller than 3. We can write again here a plus, because there is a solid line, and then minus and minus where the dashed line is. Now we actually have to rethink about what I said before. A product is positive when are both positive, so here it's positive, or both negative, so here they're both negative, so the product is positive. While here between 2 and 3, one is positive and one is negative, so the product is negative. So we're looking where the product is positive, so we have to take the regions where we have the final plus. Okay, that means that we can write the solution in this way. x less than or equal to 2, or x greater than or equal to 3. Okay, we included the equal because we have little solid balls here. And we can write this solution also in another way, as a set. This is true from minus infinity up to 2. So we write minus infinity 2. 2 is included, so square brackets pointing towards 2, and the infinity can never be included, so normal parenthesis. Union with 3 up to plus infinity. So this is actually what it means to be satisfied for external values, because on the real line, this actually corresponds to, this is the real line having 2, 3. So we have that here the inequality is true, here is false, and here it's true. The 3 and the 2 are included. So this procedure explains why the solutions is for external values. But the quick way to do it is realizing that actually 2 and 3 are the two solutions of x squared minus 5x plus 6 equals 0. So once we solve this equation, we find the two numbers, and in this case of this video, we can immediately say the solutions are for x before the first solution and x greater than the second solution. So whenever you have to solve this kind of inequality, you don't need to do again this procedure, which was just to show you why, but actually find the solutions to this equation, which is written here, and then immediately say x smaller than the first or x greater than the second. If you like the video, then thumb up, subscribe to be updated, and see you next time.